The Constitution of India. Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. We are going to learn about a new topic, which is polymer. Polymers are a group of compounds which are made up of macromolecules. Macromolecules means the molecules which are bigger in size, because as we have learned the difference between micro and macro, and we have also learnt in our 10th standard about polymerization in the last chapter, if you remember, children. Polymerization is a process where several simple molecules, simple macromolecules, they combine with each other. The repeated units of complex molecule will be formed. That is, simple molecules will combine together and they form a complex molecule. These simple molecules are heated at a very high temperature and pressure to form a complex molecule. Such a process we call it as polymerization. So this is what is called as polymerization. Now let us learn how this polymerization process takes place and what are the different types of polymers. That is, we are going to learn about the classification of polymers based on several categories. First one is the classification of polymers based on the source. So when I say source, this is a natural polymer, which means which is obtained from plants and animals. Example, you can take proteins. So proteins are obtained naturally from plants, and as we know, through the process, and this natural polymer has got a separate category. Semi-synthetic, so it is neither too natural nor too artificial. That type of polymers we call it as semi-synthetic, like rayon. The last one is synthetic polymer, which is like polythene, which we use, you know, polythene bags and covers. So that process, that polymers we call it as synthetic polymer. The next one is based on the structure. Source is something from where do we get the simple molecule. Structures are something depending on the way it is being projected, the way the structure of that polymer looks like. So the first one is linear polymer, where you have a long straight chain. Though it looks like this, it will be a straight chain polymer. Example like polyvinyl chloride. We have learnt in 10th standard, vinyl chloride undergoes polymerization to become polyvinyl chloride, which is PVC. So that is a linear or long straight chain polymer. Next one is a branched one. We know what is a branched one. So there are two polymers which will have a branch connected to each other. So such a polymer, we call it as a branched polymer. We have linear chains which has got a connection, that is a branch between the two linear chains. Such polymers we call it as branched polymer. Cross-linked or network polymer. So when I say cross-link, it may not be connected with each other directly. Maybe the first and third will be connected, or the first and second, or the second and fourth. So that is called as cross-linked. There may not be a direct link with each other, each consecutive chains, but there can be a connection with an alternate chain also. Example, you have bakelite, melamine, where these are bonded with strong covalent bond, and we know it is not that easy to break the chain. So such polymers we call it as cross-linked or network polymers. So let us now learn also about other classification. So we learned there are two classification based on source and structure. The next classification is based on the mode of polymerization, which means the way the polymerization takes place. The first one is addition polymerization. From the name addition, it is very clear that the monomer units get added repeatedly again and again. So, repeated addition of monomer units will give a complex unit. Such a polymerization we call it as addition polymerization. In this, the addition monomers will be either having a double bond or a triple bond. Now, addition polymerization can be broadly classified into two types. First one is a copolymer, second one is a Homo Polymer. Homo, we have learnt homophones in English. Homo means same, homogeneous, same. So, Homo Polymer means where the monomer unit is a single monomer, the same monomer gets added again and again to give a polymer. Example, you have polythene, N molecules of ethene undergoes polymerization to form polythene, or I can say propene giving polypropene, right? Vinyl chloride giving polyvinyl chloride. So, all these are examples where double bonded containing monomers, a single monomer undergoes a repeated addition to form a polymer. Now, we know polymer where all it is being used also. The next one is a copolymer. Co means you have a company. There is somebody who is going to join you with. So, here we have two monomer units, two different monomer units which combine together to form a polymer. So, I can take here 1,3-butadiene. You have 4 carbon atoms, the first carbon and the third carbon is having a double bond. So, N molecules of 1,3-butadiene. Diene means 2 double bonds. So, diene plus styrene. What is styrene? CH double bond CH2. One of the hydrogen is replaced by a phenyl group C6H5. So, this is styrene which combined together undergoes polymerization to form Buna S. So, this is an example of an addition polymers having copolymerization. Copolymers means two different monomer units. Next mode of polymerization is condensation. We have learnt condensation is nothing but again there is a removal of small molecules when the process is taking place. So, repeated condensation between two different bifunctional or trifunctional group, where here you can see I take a monomer unit, it will have a functional group in that. So, it can be bifunctional or it can have trifunctional, 2 functional groups or 3 functional groups. So, when this condensation polymerization is taking place, there will be a removal of small molecules like water, hydrochloric acid like hydrogen chloride or even alcohol. So, these molecules will be removed during this condensation process. So, here examples are nylon 6, nylon 6,6 and Dacron. So, example we will take the preparation of nylon 6,6. Now, how does it happens? You can take hexamethylene diamine. CH2 is methylene. Hexamethylene means 6 times of methylene group. Diamine, amino group is NH2. So, both the sides I have written NH2. Hexamethylene diamine, 2 amino groups will combine with adipic acid. This is adipic acid, children, where you have 4 methylene group CH2 4 times with both the sides carboxyl group COOH. So, this we call it as adipic acid. They combine to form nylon 6,6. So, here nylon 6,6 how it is formed, you know, right? With combined with hexamethylene diamine and adipic acid, it forms nylon 6,6. So, this is a process where condensation polymerization takes place with the removal of small molecules like water, alcohol or an acid. Now, we will go to the last type of classification based on the properties, that is elasticity, that is intramolecular forces. So, we are going to learn about the last type of classification which is based on the molecular force. So, when I say molecular force, we have learned that there are strong bonding between the molecules, or there can be weak van der Waals forces, or it can be even a hydrogen bonding. So these bonding play a very important role on the property of that particular polymer. Now properties like tensile strength, it can be elasticity, it can be toughness, or it can be durability, flexibility, or it can be its luster, any property that depends on the intramolecular forces of attraction between the monomer molecules. So what are we going to see first is elastomers. These are having the weakest intramolecular forces between the molecules. So when I say weakest van der Waals forces, what happens? They can easily be stretched, they can easily come back to its original position, means they possess some sort of elasticity like rubber. See what happens, you can just stretch and you can slowly leave it, it come back to its original position. So examples like Buna and Neoprene, they all come under this elastomers. Next comes the fibers. Fibers are having a thread-like structure. Thread means a long thread, and they have a high tensile strength, means you can just stretch it. It is actually good durability is also there for this fiber polymers, because the type of bonding that exists between those polymers are hydrogen bond. So what happens there? There is a close packing. When they assume a close packing here, they give a crystalline structure. The way it passes becomes a crystalline structure. Examples, polyamides like nylon 6,6, polyesters like terylene. The next one is thermoplastic and thermosetting. Thermoplastic. Thermo means heat. So these are linear, slightly branched polymers which softens on heating. When you heat it, it becomes a little soft, and when you cool it, it becomes very hard. They have an intramolecular force which is between elastomers and fibers. It is neither a weak force nor a strong force. There is an intermediate force of attraction for thermoplastic polymers. Examples PVC, polythene, etc. The last one is thermosetting. From the name it is very clear that once it has been set, you cannot reuse it again. So these are cross-linked heavy polymers which on heating they give extensive cross-link infusible. Infusible means you cannot fuse it again. Once it is made, you cannot rechange its shape or structure. So you cannot reuse it. Examples like bakelite. Once it has been set, you cannot reuse again for any purpose. So these are the four. So we have learned classification of polymers based on the source, based on the structure, based on the mode of polymerization, and then based on the intramolecular forces of attraction. The next we will learn about step or chain growth polymers. So till now we have been learning about the type of classification of polymers based on different modes of polymerization, source, structure, molecular forces. Here in detail we are going to learn about addition polymerization, which is called as chain growth, or condensation polymerization, which is a step growth polymerization. Now when I say addition or chain growth, we know we take a long string or a thread. When I start adding the pearls inside, it actually makes a big chain, that is the chain grows with the pearls inside. Similarly, addition polymerization is something where the same or different monomers they add continuously. So there is an increase in the chain length, or I can say the chain grows. How does it happen? With the formation of free radicals. We have studied about chain reaction in chain step. If you can remember a substitution reaction in +1, where we know there are free radicals generated, or these are also called as ionic species. So let us learn in detail about addition reaction or chain growth reaction, which has got a free radical mechanism. The first step is a chain initiation step, where the chain is being initiated, that is it is started using a catalyst, or we call it as an initiator. But here we use benzoyl peroxide, or I can use acetyl peroxide. Benzoyl peroxide, when it going to get split, what happens? It gives 2C6H5COO, and this will generate a phenyl radical. So my purpose of doing this initiation step is to generate a phenyl radical. We know free radicals are very active, they immediately try to combine with another compound. So this phenyl radical combines with ethene to form a larger free radical, where this dot from there shifts to the ethene molecule, double bond breaks, so it becomes a larger free radical. So these two steps are called as chain initiation step. The next one is propagation. What is propagation? Means development. So here the larger radical combines with another ethene radical to produce larger, more, that is one step more bigger than the previous free radical. So this continues till it reaches a particular radical that is formed with a bigger size. Now that step we call it as chain propagation. What is the last step? Terminate. It has to get end at one particular moment. So there, if I make sure that a particular phenyl radical is obtained, say we have a radical here, so this is obtained, those two monomers will combine together to form a bigger polymer, a complex molecule is formed till we reach a final stage of a phenyl radical. So once you get a free radical at a bigger size, those two will combine together to make a big polymer. So the chain goes on developing till it reaches a particular size. So this process we call it as free radical mechanism of addition or chain growth polymerization. In this, let us learn some of the addition polymers which are there for us. Let's now learn about some of the addition polymers which are there here. First is polythene. We have already learnt in 10th standard that ethene undergoes an addition polymerization to form polythene. Polythene is of two types, where we have low density polythene and high density polythene, LDP and HDP. Now low density polythene is prepared by heating or adding ethene on a repeated addition polymerization at around 1000 to 2000 atmospheric pressure, 350 to 570 Kelvin, with using peroxide as a catalyst, forming LDP. Now this LDP is chemically inert, they don't react at all. It is, though it is tough, it can be flexible also, does not conduct electricity, so it is being used as an insulation and also for manufacture of toys, squeeze bottles, etc. Next one is a high density polythene, which is prepared using ethene with hydrocarbons using a Ziegler-Natta catalyst, that is triethyl aluminium and titanium chloride, which is called as a Ziegler-Natta catalyst. And there at 7 atmospheric pressure you get a high density polythene. This is also chemically inert, though it is tough and hard, it is used in the manufacture of buckets and pipes. The next one is Teflon, which we have learnt in our 10th standard children, polytetrafluoroethene. Here tetrafluoroethene, 4 fluorine atoms, so tetrafluoroethene is C double bond C. So N molecules of tetrafluoroethene will undergo polymerization in the presence of persulfate as catalyst to form Teflon. Teflon is also chemically inert, it is resistant to corrosive agents, that's why it is used in making oil seals and also a coating for our utensils and also used for making gaskets. The next one is polyacrylonitrile, where you can see here this is acrylonitrile, CH2 double bond CHC, and this is a cyanide group which in the presence of peroxide will undergo polymerization, the double bond breaks and you get a polyacrylonitrile with N times of the monomer unit. This is used as a substitute for wool in the fiber industry. So these are the main addition polymers. Now we will get into step growth polymerization, or also called as condensation polymerization. We are going to start with condensation or step growth polymers. When I say condensation, which we have already seen before, condensation means there is a repetitive condensation of the monomer molecule, which can be bifunctional or trifunctional, with a loss of few simple molecules like water, alcohol and hydrogen chloride. So there is a repetitive condensation between two bifunctional groups, two different functional groups. There is a loss of simple molecules, and if you see, the product of each step that we get has a bifunctional species, will be having two functional groups. and each step is independent of each other, means they are not a way dependent on each other. That is why they are called as step growth. There is a growth that is developed in the each step. Now the examples you can see here, Terylene and Dacron, where ethylene glycol, CH2OH, CH2OH, N molecules of ethylene glycol will combine with terephthalic acid. We learned adipic acid, remember, CH2 4 times. In the place of CH2 you put a benzene ring, both the sides carboxylic acid, which is called as terephthalic acid, which will give a polymer which is terylene dacron, where hydrogen from here, OH from here is being removed as water molecules. The rest of the everything will be combined together. So there is a loss of water molecule from both the ends, which goes as a continuous polymer. Next one is under the condensation polymer, the first polymer which we will be studying more is polyamide. Polyamide is from examples like nylons. We have nylon 6,6 and nylon 6. Nylon 6,6, if you remember, we studied in condensation polymerization with hexamethylene and adipic acid. Remember children? So there the same reaction comes here in nylon 6,6. What is nylon 6? We have caprolactam. What is caprolactam? I have 1, 2, 3, 4, 5. 5 CH2 groups joined in a benzene ring with CO, a carbonyl group, and NH. So what happens here when it is hydrolyzed at 533 and 543 Kelvin, the ring opens, it gets splits here with a C double bond O, CH2 and NH. So the join of carbon nitrogen bond actually breaks and it becomes a step growth polymer. The next one is polyesters. Polyesters, again Dacron you can take as an example, where we studied here the preparation of terylene. That is again a polyester which is prepared by the polycondensation of dicarboxylic acid and diols. Here Dacron is a crease resistance, means it does not get dirt very easily. It is used in blending of cotton and wool. The next set of is phenol we have, which we will be discussing in the next slide. Melamine. Melamine is a formaldehyde polymer which is made up of melamine combination with formaldehyde. It is used as an unbreakable crockery. It does not break, it is very hard. So it is used in the crockery making. Here you have melamine. How the melamine structure looks? You have a benzene ring with alternate single and double bonds, 3 nitrogen atoms, and the place where carbon has to be there on the outside of hydrogen, you have 2 amino groups, 3 amino groups with 3 nitrogen atoms. When it is treated with formaldehyde, you get an intermediate. This we call as a resin intermediate, where this comes in attack here. You get NHCH2OH. One of the hydrogen from here joins the formaldehyde and you get NHCH2OH, which again splits into a polymerization, that is which comes at a step growth polymerization, where you have an opening here at the bottom and the top and also here on the side. So this we call it as a melamine polymer. So next we will be studying about phenol, where you have 2 types. One is a straight and other one is a branched one, which we will be seeing. And now let us learn about phenol. That is, I told you, it is also a formaldehyde polymer which comes under the category of condensation polymer. This is the oldest synthetic polymer, where you have 2 products, Novolac and Bakelite, which are used in paints. If you see how it is prepared, phenol, when it is treated with formaldehyde, in the presence of an acid or base as a catalyst, you get the ortho hydroxymethylphenol product, para hydroxymethylphenol product, and you have all the 3 positions ortho, para being affected by the formaldehyde group. So these are a continuous reaction. Now what happens if I am going to take N molecules of an ortho product, and when it is treated with a catalyst, I get my Novolac, where you can see CH2 being connected at the ortho position and phenol OH group at the ring substituted on the benzene ring. So this is called as a phenol formaldehyde product, which is Novolac. This Novolac, when it is being heated again with formaldehyde for a long process, it gives a step that is a branched product which we also called as bakelite. Say where you can see there is a connection of two similar straight chains which are joined by a methylene group. So, this product we call it as bakelite. This is the same step which again is repeated, but both the rings are being connected again by a methylene group. So, this we call it as bakelite. Now, we will get into copolymerization and then we will start learning about rubber. Here children, now we will just see what is copolymerization. When I was teaching you addition polymers, we learnt about Homo Polymers and copolymers. Homo Polymers are those where we have the same type of monomers being used in the addition, repeated addition. But here in copolymerization, two different monomers, that is more than one monomer is being used where both are different, they undergo polymerization to form a polymer. Such a polymer we call it as copolymers and the process is called as copolymerization. Example is the formation of Buna-S where 1,3-butadiene combines with styrene to form Buna-S, which is a tough and can be used as a substitute for natural rubber and also used in manufacture of auto tires and also for making floor tiles. Now, let us learn about rubber in detail because when we are learning about polymers, rubber plays a very major role in the polymer industry. Natural rubber, it is made from rubber latex which is a colloidal dispersion of rubber in water. Now, what are colloidal particles? When I say normal particles, they are actually very small in size and they can pass through the filter paper. But these colloidal particles are slightly bigger than the normal particles, so they are not allowed to pass through the filter paper. So, when I say nail polish, it is a colloidal solution where you cannot see the particles that clearly, but somehow the particles are getting suspended. So, colloidal dispersion of rubber in water is rubber latex from where we get our natural rubber. This is a linear polymer of isoprene. What is isoprene? 2-methyl-1,3-butadiene or it can be cis polyisoprene. Cis we know where both the same side the similar groups are present, right? Trans means the opposite side. So, this is a structure where you can see this structure getting connected to another structure polyisoprene, again another structure where they are interconnected. So, it forms a linear structure. So, this is being connected by weak van der Waals forces. So, definitely we know they have this elastic property. The next important thing is, as we all know children, this natural rubber, it is very soft at a high temperature, but when temperature becomes lowered, it becomes hard, that is brittle. It has a high water absorption capacity. It is almost soluble in non-polar solvents, but it is not that resistant to the attack of oxidizing agents. So, these are some of the physical properties of natural rubber. Because of these physical properties, it may not be having an extensive use in the industry. So, to improve, to make its physical properties more standardized, there is a process which is called as vulcanization. So, we are into the process of vulcanization of rubber to improve the physical properties of natural rubber. So, let us learn what is vulcanization. We were discussing about improving the physical properties of a natural rubber is a process of vulcanization where the raw rubber is treated with sulfur and also an appropriate additive is added along with that to a temperature of 373 to 415 Kelvin, where sulfur is capable of forming cross links between these rubber molecules, that is at the reactive sites where there are double bond present. Because we know this is 1,3-butadiene, 2-methyl-1,3-butadiene. So, there we have a double bonds, across all the double bonds sulfur form the cross links. So, 5% of sulfur is used as a cross linking agent, and after vulcanized the rubber looks like this. The structure of a natural rubber after the process of vulcanization will be like this. So, this vulcanized rubber can be used for various purposes in the industry. The next one is a synthetic rubber, which is again a vulcanized rubber which has got elastic property, stretchable property, can come back to its original position. It is formed by two polymerization. If Homo polymers, then 1,3-butadiene and its derivatives can undergo Homo Polymerization to form a synthetic rubber. If it is a copolymerization, it can be 1,3-butadiene, its derivative, with a unsaturated monomer. So here if you see, in both the process we can prepare a synthetic rubber. So synthetic rubbers are prepared by different process of copolymerization and Homo Polymerization. Next one is neoprene. Neoprene is again rubber based, which is prepared from chloroprene. N molecules of chloroprene, 4 carbon with alternate double bond and carbon at the second position is called as chloroprene, which undergoes polymerization to form my neoprene. If you see, it is resistant to vegetable and mineral oil, used in the manufacture of gaskets, hoses, etc. The last one is Buna N. We learnt about Buna S, children, if you remember, 1,3-butadiene and styrene. So here it is again 1,3-butadiene and acrylonitrile. Acrylonitrile, if you remember, children, polyacrylonitrile. Yes. So here acrylonitrile and 1,3-butadiene undergoes copolymerization, because 2 different monomers are I am using here. So they undergo copolymerization to form Buna N. So this is again resistance to action of petrol and other lubricating oil, and it is used for making oil seals, tank lining, etc. So these are the important rubber materials. Now we have come to the last part, which is biodegradable polymers. So now let's see what are biodegradable polymers. It's a biodegradable polymer. From the name it is clear that biodegradable means which can get degraded with the waste material that is under the soil and does not cause any environmental issue. Now the solid waste of the polymer, actually they cause some acute, that is small sort of environmental problems, and they are very hazardous also, means highly poisonous. So and they remain undegraded on the soil. So new biodegradable polymers have been introduced, which comprises of 2 polymers. One is polybeta hydroxybutyrate, which is used for making orthopedic devices and in the controlled release of drugs. That is the best biodegradable polymer, which is called as PHBV. It is prepared by 2-hydroxybutanoic acid with 3-hydroxypentanoic acid, which combines together with the loss of molecules, and then it gives combined product of PHBV. So this may be important to you, because they can ask you the preparation of a biodegradable polymer, which is PHBV. The next one is nylon 2 or nylon 6. Nylon 2, nylon 6, which is a complete copolymerization of glycine, which is NH2CH2COOH with aminocaproic acid, which is NH2, 5 times of methylene with amino group and a carboxylic group. The structure is not given to you, where it happens with the loss of water molecules, because we know it is a copolymerization again. So NH comes here, 5 times of CH2, there is a CONH bond and CH2 with a CO, just like our nylon 6,6. So these are the important biodegradable polymers for us, children. So learn and how it is being used for. And the last page, number 436, if you can see, a table is being given to you with the name of the polymer, monomer, structure and its uses. So try to learn this also, apart from whatever is given in the textbook. Learn the textbook. If you have any doubt, please ask me directly. Okay. Thank you, children. Have a great day.